Hey there. Alright, so in this video I'm going to be walking through how to generate a side-by-side bar plot and how to generate a box and whisker plot. But before we do that, the first thing we need to do is import our data set. I'm going to click Import Dataset, and then I'm going to click From CSV because that's how my data set was saved. And of course I'm going to go ahead and browse for my data set. Once I've selected that, I'm going to go ahead and click Open. And this is in fact the data set that I want to use. With this data set, we're looking at the salary of professors across a particular university. We also have some information about their rank, whether or not they're an associate or an assistant, associate, or full professor, their discipline, so whether or not they're in an applied department or a theoretical department, and also some information about their years since PhD, years of service that they've given to the university, and whether or not they are male or female. All right, so I'm going to go ahead and click Import. Once I do that, I'm going to pop back over to our script file here, and I'm probably just going to go ahead and run our first example here. And this is, again, our bar plot. All right. So the first thing you'll probably notice is that this is not a side-by-side bar plot. This is actually an example of a stacked bar plot, but I'm going to walk through each bit of code here for how to generate both kinds of plots so that you'll understand what each bit of code does with regard to creating those kinds of plots. So in this particular plot, we're going to, of course, we have our library command where we've opened our readxl package so that we can work with our data set. And then starting at line 3 here, we have a table command, which is telling R that we want to generate a table of values, and we want that table to be based on the data set salaries 2. And we'll see that there, that's the data set that we imported earlier. So we're indicating that the data set we want to use, and then we're selecting using this $sign the variable that we want to work with. So in this first plot, we have the variable sex, and then similarly, we've also said that within this salary 2 data set, we want to select the variable rank. So again, we're telling R that we want to generate a table of values, and that we want this information to be pushed into the variable counts using a push command here. And this is the information that R is going to use to plot our bar plots here. So, all right, to plot the bar plot, of course, you have a bar plot command, and in this case, we have a bar plot based on our variable counts here. And if we go over to counts, we'll see that we have a 2-level variable, and gender in this case, or sex in this case, is 2 levels. And then we also have our rank variable, which in this case is 1, 2, 3. So we have our 3 levels there. All right, so then we have, so that's essentially plotting that information. Then we're able to customize the plot using the following commands. The first command we have here is or at least for this customization part of the plot, we have a main equals command where we specify the title text of our plot. For this first plot, it's number of professors by gender and rank. And then we have an xlab command where we specified the label that we want to use for our x variable, which is rank. And then we have, similarly, we have a ylab equals command where we specified the number of professors as our label for our y-axis. And then, of course, we have a col command here where that refers to our color, as we see orange and red here. We're telling R that we want to use the colors orange and red based on the first color that we have here. So essentially, our first level of our gender variable, in this case males, is orange, and our second level is red, so females are red. But so that's generally how we would plot the plot. But for this example, we want to generate a side-by-side bar plot and not a stacked bar plot like we have here. And we'll look here. We see we have a we have a beside equals false or side equals F. To illustrate the difference, I'm going to go ahead and run our second example here. Okay, so again, we have our similar setup where we've generated our table of values based upon the salary2 dataset variables, discipline, and rank. Well, at least for this example, it's discipline and rank. Our first variable, discipline, is based again on our applied or theoretical department there. And of course, we have our rank with our, just as we did with our last example. And again, similarly, we're plotting our bar plot, and you'll see that again we're basing that information on the counts variable that we created there, and then we have our title text, our X lab, and our Y labs for identifying the text that we want to use for our title and our X and Y labels there. And again, specifying our color, in this case for this second example, which is dark blue and red. But we'll see that one of the different things from our first lines of code versus our second example here is that beside equals is now T, or now true. And what that's saying is we're telling R that we want the information to be plotted side by side or right next to each other instead of being plotted in that stacked version like we saw with our first example. And the importance of a side-by-side bar plot is that we're able to compare the two different levels of our variable of interest. In the second example, we have discipline. So we have an applied, whether the professors are in an applied department or whether they are in a theoretical department. So for example, we see with our first rank here, we have more applied oriented professors that are assistant professors, but then when we get to our full professors, we tend to have more theoretical oriented professors. So that is how we would generate both a stacked bar plot and a side-by-side bar plot. And also, another difference from this plot to this plot is we've also included a legend so that we're more able to interpret our different colors here and our different levels and what each means. And to do that, we used a legend equals command where we specified that we want to use the row names based on the variable counts where we use the generated information from our table here and our counts variable, and those names are, of course, our applied and theoretical levels of our discipline variable. And then I used a ylim command to set the range of our x-axis. Instead of just stopping here at about 80, I went ahead and extended that our y-axis range out to about 100. That seems more reasonable in terms of typically how you would see this graph displayed. And then of course I changed our beside equals false command from our first example to true so that we displayed our information side by side. And that's how you would go about creating a side-by-side bar plot in RStudio. But next, we're going to shift gears to our box and whisker plot. So I'm going to go ahead and plot our first example here. Run. There we go. All right, so this is an example of a box and whisker plot. And a box and whisker plot displays the range and distribution of the data by plotting their quartiles. So you have the first, second, and third quartile with their extreme values at the whiskers here. and we also see that we have some outliers in this particular data set. And the median of this particular data set is about 100,000 in terms of salary there. All right. So similarly, as we had a bar plot command, we also have a box plot command. In this box plot command, of course, is telling R that we want to plot a box plot. And within the salary sheet data set, we've selected the variable salary, and then we used a ylab command to specify our y label, which is salary, of course. And then, again, using our main equals command, we were able to specify the plot text for our title, which in this case is box plot distribution of professor salary. So, all right. So this is an example. This first example is an example of an overall bar plot. Overall box plot, box and whisker plot of the variable salary. So across all of our professors in this sample, we have a box plot, a single box plot here that displays the entire distribution. And so in order to really interpret this, the distance between the points in the box plot tell us about the distribution of the data in their quartile. So basically what that means is, in terms of distribution or spread, the further away this extreme score from our quartile here tells us that these are pretty varied in terms of salary, but as we look at our lower extreme score, the whisker is a little closer together, meaning that the data for our lower end are typically a little more bunched together. But that's kind of how we would interpret this particular kind of plot. But let's go on to our next example of a box and whisker plot in R, because we don't want to just report one variable. While that has meaning, we want to also see how this variable plays out across another variable, such as rank or years of service or something like that, so that we're able to compare how our distribution is faring across our key variables of interest. So I'm going to run that, and there we see we have the same, we have a different variable here, which is years of service, which is displayed by rank. So again, we have our box plot where we specified, this time we're specifying the years of service as our key variable of interest, and to tell R that we want to display the years of service box and whisker plot across rank, our rank variable, we use this little squiggle sign here, which is called a tilde sign, and then we specify the variable that we want that information to be displayed by or displayed across. So in effect, what we have is our salary variable displayed across the variable rank. And then we've also specified our y equals, our y lab equals salary. Oops, I'm up here, sorry. Our y lab equals years of service there. And then our title with our main command equals box plot distribution of years of service by rank, and then we see box plot distribution of years of service by rank. And if I wanted to, I could add an X variable. Oops, there we go. Equals there we go. If I were to run that again, we see that now both axes, both x and y axes, are labeled. All right. But the only difference this time is we're unable to tell which, like I know this is rank 1, this is rank 2, this is rank 3, but when they're black and white like this, it's a little harder to interpret. So we're going to add some customization here. So I'm going to go ahead and run our next example. And click run. All right. So with this example, we've added some color there using a col equals command where we specified the color blue, green, and yellow. Blue for assistant, green for associate, and of course yellow for our full professors. But you wouldn't know that unless I told you because I don't have a legend here. So I'm going to go ahead and run our next bit of code, which generates our legend. And there we go. So this makes our plot a little more legible. It's a little more neat and organized and easier to look at. But that's how you would generate a box and whisker plot in RStudio. With our legend here, we have a legend command where we specified the area in our plot where we want to generate our legend, which in this case is the top left because we don't want to interfere with any of our data points here. And so this top left area, this blank area, was the perfect solution there. And because I didn't want any space between my y-axis and my legend, I used an inset 0.00. You can also use 0.0. The point is that that value is 0. So that, in other words, there's no space between my y-axis and my legend. And then again, this time I use a title command, but it's similar to our main equals command, except for this time we're titling our legend. So the title of our legend, we're looking at rank. This is again our rank variable, and we've indicated which level is which using our legend. And we did that using a C command here, which specifies our sequence, and that sequence is assistant, associate, and full, and then we see assistant, associate, and full. And I used a full equals topo dot colors with parentheses 3, close parentheses there. This command basically tells R that I want to fill in the colors of the legend based upon typical Word document colors, and I want those colors to be 3 different colors. And so you'll see I matched I kind of worked backwards and matched these colors, or I generated these colors, and then I matched these colors to the colors in my legend. That way everything's succinct and everything works together, and we're able to actually use our legend. And then this hors equals true command displays our legend horizontally instead of vertically. So if it were vertical, it would go assistant, associate, and full. But as you see, as I get lower there, we would still be interfering with our data, and that's not what we want. So I displayed the legend horizontally, and our CEX equals argument here is set at 1. Basically what that is doing is telling you where around the edge of our plot I would like to display my legend. So if I shift gears here, oops, let's go to, oops, there's your assignment, yay. There you go. All right, so here we have, again, what I was talking about with our inset value. This is set at 0.5, so it's adding that little bit of space there. But I didn't want that space, so I used a inset 0 there. But we're looking along the axes saying, okay, within this region, this top left region, where do I want that information to be displayed in our legend? So Again, I used a 1.0 command there, or 0 value, to indicate that I wanted my legend to be displayed in the top left, and within that region, I wanted it to be displayed flush against my y-axis here, to again avoid using up too much space that would cover my data points. But that is how we would use and generate both our side-by-side bar plot and our box and whisker plot in RStudio. Cheers.